Hello everyone, welcome back. In this submodule, we will look into the various policy and the technological interventions that are required for understanding the sediment management or the sediment dynamics within the watershed management. We see that India requires significant transformation in the context of water resource or the water resource management. The main reason is that the practice of water resource management has undergone large changes in the past 4 decades or so, and the profession is gradually becoming more multidisciplinary. So, besides having a knowledge of hydrological principles, there is also a need to know about the interlinked sectors like agriculture, geology, environment, forestry, management, social science, economics, law, etc. It would be sometimes necessary that some of the experts, which would have expert knowledge from these backgrounds, a strong monitoring mechanism has to be developed when we talk about the various relevant sectors, the academic institutions, or the R&D institutions and various NGOs, in order to monitor what are the various challenges and what is the ground realities that needs to be tackled. So technology plays an important role in assessing the water quality or the water characteristics. However, the current technology's readiness level is very low. There is a need to assess technology from various viewpoints, for example, reliability, its robustness, its resilience, and redundancy perspectives. Selection of appropriate technology is one of the crucial challenges which is faced by authorities today. Today, there are various sediment management techniques such as the watershed management, catchment area treatment to prevent sediment ingress from the catchment. There are various techniques to handle the sediment in existing reservoirs, for example, sluicing, drawdown, flushing, and providing large-size deep outlets. Coordinated and synchronized reservoir operation and sediment management approach is essential for projects in the particular watershed. Now, when we talk about the various technological interventions, extensive siltation studies are need to be carried out. The standard operating procedure for all of this desiltation of reservoirs needs to be developed, keeping in mind the various stakeholders that are there. The academic institutions like the various IITs or the IIC can use modern techniques for the assessment of sedimentation rates, volumes, and reservoir capacity, which would include modern techniques like bathymetric survey, satellite remote sensing, hybrid method using both bathymetry and remote sensing. They could also integrate the differential global positioning system. Besides the use of these geomorphological parameters for the quantification of sediment volume and the impacts of sediment on the morphology of rivers, very much emphasis can also be done on the basic and applied research which is needed to predict the river response to the sediment dredging and understanding the river morphology. Detailed comprehensive investigation and modeling which would integrate the various GIS techniques would also be essential to assess the sediment flow or the sediment transport within the watershed. Now the institutional or the governance challenges. The first is there is a lack of expertise or skilled manpowers which critically affect the efficient functioning of the infrastructure and thus the implementation of a proper sediment plan within the watershed. There is a lack of the detailed policies which support the recycle and the reclamation of the wastewater as well. There is a need to provide comprehensive guidelines for the use of recycled water and to recycle water. The implementation of the 6 Rs is a major challenge as the stakeholders are habituated to the linear use of water resources. So on one side, the environmental benefits are easier to understand, but on the other side, long-term economic benefits are more difficult to quantify and envision. This is especially true when we talk about the water quality assessment, the differential water quality that needs to be kept in mind when we talk about the different applications that are there. Large scale implementation of the treatment systems, again it requires a drastic change for the water that is supplied to the various industries, to the households, and for the other agricultural needs. Apart from that, there is a lack of awareness amongst the various citizens about the water scarcity, the water usage or consumption, or how the sediment basically affects the water quality and other characteristics. Thus, in order to reduce sediment flow into the watershed, sustainable techniques must be used. Some of the action would include studying the watershed characteristics, which would understand the local sediment dynamics that are there, and then assessing the vulnerability of this watershed in terms of soil erosion and sediment production, which can be done using modeling, and then to identify and prioritize the degraded watershed for treatment. Then the treatment of the watersheds would be done with biological and engineering control measures that are there. And then, for example, there would be a stream bank erosion control using river training works like construction of spurs, There would be other infrastructure for the trapping of sediment upstream of the river before entering the reservoir. So some of the infrastructure may be developed for this, but again, this would require proper policy backing and proper data collection that is there in order to assess the local conditions that pose the major challenges in the particular watershed. Coming to what are the various policy and institutional frameworks that would require. So when we talk about the national policies, we must implement policies like the national water policy, which would emphasize the need for integrated water resource management, including the sediment management. Then adopting guidelines for sustainable sediment management in the river basin management plans. There needs an institutional coordination between the various government agencies like the Central Water Commission, Ministry of Jal Shakti, various state water resource departments, the renewable energy ministry. So all of this requires collaboration between the various departments, various organizations that are there in order to come up with an integrated common plan. It would also involve engaging with the local communities, various NGOs, in order to make the sediment management initiatives holistic of what are the requirements or what are the actual challenges faced on the ground. Now, allocating these dedicated funds for the sediment management programs would be very much required under the national program. So we could have the Pradhan Mantri Krishi Sinchai Yojana or the Manrega program would be there. We could have some allocated funds in order to develop the sediment management related programs or some sediment management related techniques within the watershed. There could also be financial initiatives to farmers and owners for adopting soil conservation practices so that excess of soil erosion does not take place within the watershed. Then there is a need to have proper public awareness and education between the various stakeholders. Conducting awareness campaigns can be done to educate the public about the importance of sediment management and how does it directly affect their health and the other economic activities. Promoting a community-based initiative for local sediment control and river management would be very much a priority. So in order to understand how this can be done, we can take a look at the lowest plateau in China. It covers some around 640,000 kilometers square in the upper and middle parts of the drainage basin of the Yellow River in China. So they took a project to achieve sustainable development in the lowest plateau by increasing the agricultural production and income and improving the ecological conditions in the tributary watersheds, especially by reducing the sediment overload in the river. It covered around 1,100 micro watersheds and included the severity of soil erosion, poverty level, experience with soil and water conservation works, the development potential, and the repayment capacities, which is also coupled with strong leadership and commitment at the local government level, and the proximity to science and research organizations which are involved in the soil and water conservation techniques. So the project team identified the areas which faced the greatest difficulties. Then they designed sustainable local development plans with the communities. And throughout the life of the project, extensive use is made of various maps to monitor the progress in the micro watersheds and to get an overview of the impacts over the whole basin. So if we can have develop some an integrated watershed management plan for our own micro watersheds, that can be of very much crucial importance. Similarly, in India, when we talk about the Sardar Sarovar Dam, which taps around 60 to 80% of the sediments carried by the Narmada River before it reaches the Arabian Sea. It experiences high sedimentation rate and results in the settling of organic matter. There were studies that show a decline in the nutrient supply, which affect the primary productivity and the carbon fixation in the Arabian Sea. So regular monitoring of large reservoirs to understand the nutrient transport, the sedimentation that is happening there, it is very much crucial. When we talk about the environment impact assessment reports as well, when we talk about Assam, its longest river is Brahmaputra. So the Brahmaputra has been claiming more ground by eroding its banks. Now when it was first surveyed over the years 1912 between 1912 and 1928, the river covered an area of 3,870 square kilometers. This has increased by 50 to 57% by the year 2006. So proper monitoring needs to be done to understand how the river morphology has changed over the past decades, how the water availability and the water characteristics have changed, and how we can basically look into predicting or integrating some modern day technologies to make water available and accessible to all. For this, we would require proper sediment management in the watershed. This would require assessment of what are the various land use changes that have happened over a particular watershed that we are talking about. And then once the data is collected, we can identify what are the major regions that are facing the most challenges. This can be called the hotspot areas. And then based on the various case studies that are there, or using or with the various experts that can be brought in from various domains, appropriate catchment area treatment and land use planning can be developed. So as I mentioned, various check dams can be built. Engineering environmental techniques like afforestation, staggered trenching and all can be done in order to make the soil more stable, so that less soil erosion happens and less sediment influx is there within the water. The identification of the hotspots in a particular watershed may be carried out by prioritizing the action plans for sediment management, which would help in targeted, cost-effective interventions. It is recommended to quantify the sediment load in order to identify effectiveness and types of interventions that are required. The action plan for sediment management would involve three components. The first would be the catchment area treatment works in watershed, which would involve the forest, the soil conservation, and then sand mining for the various river beaches, which would involve geology, mining, and then bank protection works for erosion control. There would also be desilting of irrigation canals. Thus, what we require is all of these plans should be integrated within a watershed. So there should be an integrated watershed management. This is a method which involves handling human activities and natural resources on the watershed basis, and it allows for the conservation and development of water and other land resources. The agronomic management methods integrated with soil and water conservation and development techniques can reduce the impact of erosion and the sedimentation processes. This would help to maximize the infiltration potentials of the soil. The agronomic activities can include the crop and vegetation management, crop rotation, shifting cultivation, grazing land management, etc. But all of these plans would not be beneficial unless and until we could identify the specific stakeholders and then target the policy initiatives based on their varied expected changes that are there. The watershed provides many important services to an extensive ranges of stakeholders, and changes in the land and the water management and in the watershed hydrology will directly or indirectly affect many or all of them. So many people use the upper and lower reaches for multiple purposes, and a plethora of public and private agencies are typically involved. So there would be organizations dealing with agriculture, animal husbandry, forestry, water, irrigation, rural development, physical planning, various local governments, community institutions, NGOs, and so forth. This institutional density creates a management challenge and requires watershed management approaches to create broad and inclusive institutional platforms. The upland areas of developing countries like India are typically more fragile and less productive environments where the natural resource management and rural poverty are commonly linked. Improving the management of natural resources and influencing the downstream impacts requires attention to the problems of the population in the upland areas, particularly when we talk about the poverty reduction and local institutional development. Thus, the watershed management programs generally have to focus on the various farming systems in the upland areas and to see how the water quality affects the population, how the various sedimentation processes are hampering the distribution or the accessibility to water. In this, the underwater domain awareness, which is proposed by the Maritime Research Center, would empower the people on the ground to participate in the economic growth story when we talk about the water resources management, having a minimal impact on the nature. This would lead to an enhanced situational awareness, which would allow to navigate the sustainable development goals as well. There would be use of technology to generate real-time UDA in a unique and optimal way forward. There would be a digital ocean construct which would bring more transparency, just like the digital ocean construct which brings more far transparency into the underwater domain. We could have a digital water depository having all of the data surveys that are conducted for data quality, the data, the water quality, the water assessment, the water flow and all. We could have a centralized digital water repository. For this, a single tool would provide significant UDA for the multiple applications across the various stakeholders that are there. Apart from that, the real-time appreciation of the conditions and their extrapolation to the aquatic or the marine life health and growth would have numerous applications as well. Various policy and technological intervention inputs can be brought in, which would be required for confidence building measure for financial institution and a startup ecosystem to indulge in such community level activities. An institutionalized approach would be required so that we could build a national, regional, and a global initiative to balance the people, economy, and nature interactions. Thus, an inclusive approach would be able to address the concerns of the communities and the stakeholders simultaneously would be very much critical in this. The socio-political, socio-economic, and the socio-cultural harmony would also be included, leading to sustainability of the watershed management techniques or the watershed management plan. Thus, what is required is how to integrate the sediment management plan within this national framework. How can we harness the role of UDA in sensitizing the various stakeholders that are there, bringing their viewpoints, what are their demands, what are their challenges, we can bring them all forward. And then using this collaborative approach, how can we undertake a common data collection program, we can have an integrated platform so that a particular policy can be brought in which would integrate again marine special planning as well. Various stakeholders, their demands along with the data can be brought in a single integrated platform, which would be supported by the skilling of workforce in the various expertise, the various domains that are required to sustain a proper watershed management plan, which includes the sediment management. So with this, I'll end the discussion here. Thank you.